Hello, everyone. We are the Electric Boat Underwater Wireless Data Transfer Team, and we are so excited to share our senior design project with you all. First off, we would like to introduce the members of our team, who are Ryan Young, Daniel Byrne, and me, Frank Marks. Ryan fulfilled a project managerial role by carrying out communications with the point of contacts at Electric Boat as well as our Yukon faculty advisor. He and I worked together to set up the TCP connection used for the backbone of the program and integrate TLS security. Daniel, meanwhile, worked to integrate Reed-Solomon error detection to make sure our communication is reliable. For underwater communication, the team elected to leverage the Transmission Control Protocol, also known as TCP. With its plethora of benefits, TCP also allowed the team to implement Transport Layer Security, known as TLS. TLS ensures the data being exchanged is done so in a secure fashion. This is achieved by using keys and certificates to encrypt the data being sent. Encryption makes sure that only the two verified parties can read the message being exchanged. With a secure connection, the team focused our attention on potential data errors that would occur from transmitting data underwater. To combat this, we implemented Reed-Solomon error detection into the connection. This detects and corrects errors in the data so that the receiving party gets the correct data even in error-prone environments.
Thanks for the great introduction, Frank. Now we're going to get started on the error detection and software demo. In this Linux virtual environment, both sides of the program, the server side on the left and the client side on the right, are displayed. An important note is that due to TCP, the server will always have to be running before the client runs, and the client always starts the conversation. When starting both sides of the program, we are asked two questions. Would you like to see Reed-Solomon codes? We're going to say yes to this on the server side, and we're going to say yes to this as well on the client side. And then our second question is, would you like to simulate error? We're going to say yes to this on the server side, and we're going to say no to this on the client side. Once we've answered those questions, we can begin the data exchange. To start, we'll send the string hello world from the client to the server. The key to remember here is that we answered no to error simulation on the client side. This is important because it allows us to compare Reed-Solomon codes and prove our error correction is functioning correctly. Now we can compare the Reed-Solomon code that was sent with the one that was received. It is clear that they are the same, and this can be proved using our Reed-Solomon text conversion script. So what I'm going to do now is I'm going to copy the Reed-Solomon code from the client side and paste it into our script. And as you can see, the hello world with the padding matches what we sent. Now, what we can do is we can check the server side as well, copying this Reed-Solomon code and pasting it again just as we did the client side. And as you can see, it's the same. So now, if we send the same text back, and remember the server side has error simulation turned on, we can see that if we copy this Reed-Solomon code and we try to input it into our script here, we can see that the encoding is messed up. Mainly we have 3 pound symbols in hello, 1 pound symbol in world, and we have another one in the padding. So if we go to the server side or the client side and we check out what we received this Reed-Solomon code. We run it back in our conversion tool, and we see that we get hello world properly. And this is confirmed by the decoding's output, which is hello world. And now Daniel's going to give us an overview of the math behind Reed-Solomon codes.
So, how does this help us construct a message? Well, we can encode the message as a polynomial. So, for example, if we just had a two-part message, we could actually just embed those as coefficients of line. So, for example, if we have message part A and B, it could be y equals ax plus b. Then, what we can do is we can sample the line more than twice. So, for example, if we take 4 points, but instead, across the transmission, there's some error, and it becomes, instead of that nice line, it becomes this, 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 this. What we can actually do is we can correct for this error and get the line that was supposed to be from that.
As a team, we'd like to say thank you to our sponsor, Electric Boat. Eric and Robert have been fantastic and super helpful throughout the whole year. Our advisor, Professor Scoggin, and the University of Connecticut. We'd like to say thank you for putting this experience together for us, and it's been truly awesome.